Okay. 3, 4.
Oh, okay. So overall, it's a small minority, I guess.
Yes.
Okay, so maybe we'll have to incorporate the basics, the elements, just the foundational aspects of R in tomorrow's session. So I'm going to change the overall curriculum a little bit. The goal was to provide you some high-level understanding of your role as a data scientist, but we're going to adapt that a little. But whatever the case, you're going to learn a little and hopefully be able to take some things to apply in your careers or in your daily work. So we're going to cover data science in R. We plan to have other sessions where we're going to cover data science in Python, data science in Rust, data science and other programming languages that are key to engineering. But today's session, or this session for the next 2 or 3 days, is just focused on the R language. So let's get started. So who is a data scientist? That is a very, it's a simple question, but the answer you will get will depend on who you ask. So I thought we'll look at some job postings from some of the key agencies and see what they expect of data scientists. So who, from the perspective of these organizations, who is a data scientist? So this is the Department of the Treasury. And this is the responsibilities that they have described as being those in the powerhouse of a data scientist. The person should apply professional knowledge of computer science, mathematical statistical theories, techniques, and methods to gather, analyze, design, and construct new processes for analytical modeling, interpreting models, and or reporting quantitative information, trends, relationships, and correlations among or within data. And of course, to advise on the potential benefits or uses of automation to improve the efficiency of program operations, and to analyze a variety of data sources to provide data-driven insights to the organization. So that captures quite succinctly, I would say, what is required of a data scientist. Now let's go to tech. And let's see from a tech perspective, let's say from Google. When Google is hiring you as a data scientist, right? What qualifications or what kind of responsibilities are you expected to have? Of course, many of you are going to be drawn to the pay range, 177K to 266K. But let's look at the responsibilities here. The first is collaboration, which I think is awesome because I think that's one of the hallmarks of data scientists. You're going to work with a lot of people, as we're going to discuss in a few slides from now. And you should be able to translate and refine business questions into tractable analysis, evaluation metrics, or mathematical models. You should be able to use custom data infrastructure or existing data models as appropriate, and to design and evaluate models that will solve questions or solve problems. You should be able to gather information on business goals and priorities and answer those questions with new data or with existing data. And you're supposed to own the process of gathering data, extracting and compiling data across various sources with a whole variety of tools to answer questions that are of business interest. So again, that gives us a snapshot into what a data scientist or who a data scientist is supposed to be in the business context. And then lastly, let's look at OpenAI. This is the owners of ChatGPT. So if OpenAI hired you as a data scientist, what are you expected to do in that role? Well, you're supposed to embed with the human team to uncover new ways to improve data quality and output. You are expected to define and interpret tests that help answer critical questions about the impact of modal UX changes and process changes on their overall outcomes. You're supposed to help establish a data-driven and development culture by driving the definition, tracking, and operationalization of various metrics of interest, and to develop dashboards and other things that are data related. So again, those three companies, organizations, by looking at their responsibilities as advertised for jobs, gives us an insight into what data scientists are supposed to do. Now, there are two ways people think of data scientists. When you say the word data scientist, people suddenly think of some very, very hyped up things, which of course are within the powerhouse of a data scientist, but are not done that frequently. And so some of those things include like, oh, the data scientist is just working every day to develop these groundbreaking AI models, or they're building fully autonomous systems. They are predicting, trends in the market, in the stock market. And then, of course, big data, right? People always imagine, oh, data scientists must be working with big data all the time. Of course, they work with big data, but we're saying that these things, they happen, but not as common as you think. And then, for some, they think data science is synonymous with deep learning, right? It has to sound very sophisticated and very cool. And then other things like algorithmic trading and virtual reality and quantum computing and all of those are things that, again, all of those things are things that data scientists do. But unfortunately, to disappoint you, the day-to-day job of a data scientist is way, way more boring. Here are the things that a data scientist does on a day-to-day basis. Data cleaning and preparation, exploratory data analysis, feature engineering, very, very important. Data visualization, collaborating with stakeholders, writing and maintaining code, documenting code, having, code review sessions over and over, and then reporting of, outcomes from their work. And of course, you have to keep learning, because again, if you are solving problems, you'll be faced with challenges which you don't know how to address. So you have to learn to figure those things out. So the day-to-day job of a data scientist, this about sums it up very nicely. Again, this is just the same thing we said earlier, but in just a pictorial form. Now, how did this field of data science come about? It's a relatively new field, and it's a hybrid of two different specialties. We have a field of statistics and a field of computer science. So you can think of data scientists or data science as a marriage of those two fields. So a data scientist knows more about statistics than a computer scientist, and knows more about computer scientists than a statistician, right? So we've pulled some things from data science and pulled some things from computer science, and together those created that field of data science. And again, that gives some ideas to what the data scientist does day to day. So is there a difference then between a statistician and a data scientist? Well, it depends on where you're working. In some places, statisticians call themselves data scientists, but technically there is a difference, at least in our organization. The goal of statistics or a statistician is to prove. The goal of data science or data scientist is to improve, right? And therein is the difference. When I hire a data scientist, I am hiring him specifically to improve processes with data. So both of them work with data, but a statistician is trying to prove a hypothesis that indeed there's an association between X and Y, that indeed smoking is associated with lung cancer. You're trying to prove a scientific hypothesis. That is the goal of statistics in the context of data. But data scientists, if I'm hiring you, of course, I'm not hiring you to come and prove any hypothesis. I'm hiring you to improve processes. How do we improve our process for X, Y, and Z? How do we reduce costs or wastage? How do we improve efficiency? Right? Those are the things that I'll be hiring data scientists to do. So that is a nice way to summarize, at least from a very rather simplistic view, but at least that's one way to understand the differences between a statistician and a data scientist, even though they are cut from the same cloth to some extent. So the question then is, what language should you program in as a data scientist? Should you use, of course, there are many options there, but the two most debated ones are, oh, should I use Python or should I be using R? Well, it depends. Like we said, a data scientist is a hybrid of two fields, statistics and data science and computer science. The question is, your job duties, do they lean more towards statistics or do they lean more towards computer science? If your job duties lean more towards towards statistics, then it makes perfect sense for you to be using R, because R is a beloved language by the community of statisticians. Statisticians love R. And one consequence of that is that you see a lot of packages in R for almost anything you want to do in statistics. I mean, there are very few things you'd want to do in statistics that you won't find an existing package in R already. So it becomes an issue of just efficiency at that point, that you just grab an existing package and you use it for your work. Oh, by the way, for those who may not be familiar with packages, package is like a tool to do everything. You know, if I want to do, let's say, a particular type of analysis, I need a tool that will help me do that, right? So we'll call those tools packages. Packages are written by people in the community. So, you know, R is open source, and so you have a very large community of statisticians who are very active in that community and who write packages all the time. So if your work tends more towards statistics, then you will be very, very, it makes a lot of sense for you to use R for your work. Now, if your work tends more towards the other side, towards engineering, you're working with APIs all the time, you are building processes, data pipelines, you are things that are more towards engineering, then it obviously makes sense for you to use Python. So it's not a question of whether one particular language is better than the other. It's a question of what are you doing in your day-to-day tasks. If they tend more towards statistics, then you use R. If they tend more towards computer science, then you use Python. It's pretty basic. Now, I want to also clarify that writing code doesn't make you a data scientist. That is very important. Anybody can write code. I mean, if you're dedicated enough, in 6 months, you'd become proficient in any language, you know, whether it's, you know, C# or Python or R, right? You know, whatever language it is, 6 months of just dedicated learning will make you quite proficient in writing code, and at least if you are reading the instructions and solving the problems, it's pretty easy. And I mean, in the age of ChatGPT, that's easy. However, being a data scientist is way more than that. It is the art, the ability to solve problems. And problem solving is not the same as writing code. Problem solving is also agnostic of the language. I could, like in Chi-squares, when we have problems, anybody can write a solution to that problem in any language they are familiar with. Once the sub-problem has been solved, translating it into any other language is just as simple as ABC. So problem solving is agnostic of language, and problem solving is not the same thing as writing code, right? So it's about how do you think about problems? How are you able to take a big problem and break it down into small pieces? Now, from an entrepreneurship perspective, the problems you're solving must meet 2 criteria. There must be problems, real problems that address pain points, right? In tech, it's very common to see people who create, you know, solutions that are looking for a problem, right? You know, so that doesn't make sense. Like, okay, so we have built a solution now. Who is going to use it, right? That doesn't make any sense. So you have to solve real problems that address, you know, pain points faced by a lot of people in the real world. And from an entrepreneurship perspective, there has to be money in the problem. If there is no money in the problem, then it's well, that means you are the government. It is the government's role is to do things which people are either unable or willing or unwilling to do, right? So again, I'm sure most of you here have, you know, maybe you're building a product. That's my assumption, at least, that some of you are in the infancy of building a tech products, and you're like, okay, how do we do this? So you have to really be deliberate about the kinds of problems you choose to solve, because for it to be sustainable, it has to be profitable. I mean, so how are you going to, you have to pay your staff, you have to engineer new features, and all of those things cost money. And so solve problems that are a real problem, not imaginary problems, and make sure there's money in the problem you're solving. Again, this is just to iterate, to emphasize that solving problems is more than writing code. Like, I can't tell you how much time I spend just writing, you know, in my tablet. When I have a problem, it's just endless writing and sketching and thinking about the problem, and, you know, writing it down and figuring out all the possible ways that data could flow or things could happen. the writing of a code is the last stage. If I can figure out the problem and how it flows, then writing the code is very easy. So for you to be a good data scientist, you must have the ability to see the problem in your mind in 3 dimensions. You need to be able to conceptualize the problem from just an abstract idea to something that you can almost feel and touch in your mind. Because if you cannot see it in your mind, then how do you solve the problem? How do you then say, okay, this is how it flows from here to here, and this is how information flows from there to there, right? That is a fundamental part of solving problem solving. You have to first of all conceptualize it and put it down on paper. And then later on, you can write the code. Like I said, the writing of a code is the easiest part in the whole process. You have to first of all solve the problem in your mind first, and then put it on paper, and then the rest is easy. So what makes a good data scientist? This is my own criteria for what makes a good data scientist. 1, imagination. I cannot emphasize enough the power of imagination. Imagination, any day, anytime, I'll pick imagination over knowledge. Knowledge is very finite. The things you know are very finite. Imagination is infinite. You can imagine about things that you have never heard about, never seen before. And people have the ability to imagine things. I mean, like, you hear people imagine that, oh my gosh, if I had $1 million, I'm going to do this. So I'm like, okay, it's very clear to me that you have the power of imagination. Now we just have to steer that imagination from just daydreaming to actual, problem solving. And so I think that is very important, right? The ability to imagine things, because if you cannot imagine, then you can't innovate. And I also think it's very important that you retain the power of being surprised. I mean, for me, I always repeat that a lot, because I think it's very important. When you fly from point A to point B and you're in the plane, you should be shocked that, oh my gosh, I am flying thousands of feet above the ground and I'm not falling. Like, what if you pick a phone and you make a call? You should be surprised that, oh my gosh, like, I'm talking to somebody who is thousands of miles away. Because I think that the gift of surprise makes you realize that, oh, human beings like me are the ones that engineered this. I mean, these guys had 1 head, 2 legs, just like me, and they came up with this amazing engineering feat. And that challenges you, in my opinion, to really say, okay, what can I do? So I think imagination is deeply tied with the gift of surprise, because when you are constantly surprised by innovations around you, you start thinking that, wow, I wonder how they put these things together. And you're constantly on the lookout for how you could also see gaps in, engineering, or gaps in, technology, and solve those things as well. So I think imagination is very, very important. Secondly, paranoia. Paranoia in this context means that you should always be paranoid that you've made a mistake. That keeps you on your toes, because you won't just write some code and just push it, right? You write a code and you go back over and over and over to make sure that you've not made a mistake. And so that's what I mean by paranoia in this context. The fear that, wow, I've made a mistake, and that just constantly makes you to keep on guard, against, bugs, and against, just human errors that could jeopardize an otherwise excellent piece of work. And then obsession. Obsession in this case, you have to be obsessed with the problem. Like, if you have a problem you're solving, like, that should occupy your every waking thought. That is how you create great products, because you're obsessed. There's no great thing that is easy. Of course, there's a reason why not everybody's doing it, because it's hard. And so if it's hard, that means that the solution is non-obvious. And if the solution is non-obvious, it means that you got to be obsessed before you can figure it out in a way that makes sense. A good data scientist also has to be customer-oriented. And so that means that if a customer provides feedback, you take that feedback and you say, okay, obviously we have to go back to the drawing board. We thought we did great, but people don't understand what we did. And trust customers for them to completely misunderstand whatever you did. And trust customers also break any technology you build. And so being customer oriented means that you just go back to drawing board over and over and you address those issues. You also have to be time oriented. And when I talk about time, I look at time in two domains: time to production and time in production. So time to production simply means that if we are trying to build a solution, how much time am I spending to write the solution, right? You have to understand that especially if you work in the business environment, there are business requirements. There are also other people who are trying to solve the same problem. So you got to be fast. You got to move fast, right? So being quick on your toes, being able to think fast, so that the time to production is reduced. And then when you've pushed your code, how long does it take for this code to be in production? Now we're talking about, okay, what kinds of quality assurance and what's the speed? How do you communicate those things to members of your team, right? So that everybody does their own part to make sure that the time between you push your code and the time to which users start to use that feature is reduced. So time-oriented means that a good data scientist is very conscious of both time to production as well as time in production. Collaboration is extremely important to being a good data scientist, because you realize that you are not a one-man team. Of course, you're not. You are surrounded by a whole lot of other experts. You cannot work in a silo. It doesn't matter how excellent you are as an individual contributor. If you cannot communicate with the team, then all is lost. And so contribution starts with documentation. Please, for those of you who write code, write your code as though you understood that everybody on this team is going to review your code. So document your code, provide notes, especially if you're doing something that is not very obvious, right? Make sure that your code is well documented. And so that is a key part of communication. And so these are the key members of an engineering team. Of course, there are more, but these are just the basic ones that I have put here. You have the UI UX. UI UX means user interface, user experience. Those are the product designers. So the product designer will say, okay, we want to collect data from this form. How best can we design this form so that people can fill the information clearly and it's seamless, and we capture the data in a way that makes sense? And then you have the front-end engineer. The front-end engineer, whatever you see on a web application, well, you are seeing it because the front-end engineer worked on that. So they're responsible for validations. If you provide a wrong entry and it says, well, this entry is invalid, well, that's the work of a front-end engineer. All the user interactions are engineered by front-end developers. The back-end engineer is responsible for the question, what the data is in. So if you have a data set, obviously we're collecting data in a database, right? So backend engineers are all about how do we store this data so that we can retrieve it, we can process it. And then we pass the data to the data scientist, right? Data scientist is now responsible for what is in the data. How do we get insights from within the data? And so the data scientist is responsible for the structure of the data, the analysis and interpretation. But you can see also that from here, one of the core requirements of a data scientist is, if I'm building a platform for, let's say, data collection, the data scientist has to think up front and say, how will the data be analyzed so that the database has to be set in a very specific way so that we collect the right kind of data. It can't be medicine after death. So you can see how, even before we talk about, the data from the back end, the data scientist is very, very key. And so you can see how communications is very key between the data scientist and the backend engineer, the data scientist and the UI UX, because the data scientist is going to tell him that, well, the form you've designed, it makes sense, but here are some problems with the form. Please, redo your design so that the responses are going to be closed-ended and so on and so forth. The data scientist is going to review the work and tell the front-end engineer that, well, I can see that you've not added so-and-so validation. People are able to enter values like negative numbers, even though this metric we're asking for is just positive values only. We're asking for age and somebody can still enter negative values. Please, can you add the validation and make sure that people cannot enter negative values? So you see the data scientist is involved with communication there too. Data scientists can also tell the backend engineer that, well, we want the data in this specific format. We want the data to be in this this particular configuration so that when we get the data, we can analyze it. Again, the role of communication. And then the QA engineer, of course, the data scientist has to communicate with them to say, okay, please, can you kindly test for this? Or, oh, I see that your test flagged this as an error, but here, this is actually not an error. This is not a bug. This is actually a feature. So please don't be overzealous. So the data scientist the point I'm trying to make is that the data scientist is a key part of the engineering team, but they have to communicate with everybody on the team before you can get good results. So what will make you a bad data scientist? So these are some characteristics that you really want to stay away from. All API, no KPI. API is just a technical thing. It's when we write code or we build features, we use APIs. API is application processing interface. So essentially, you can think of that as a chef. A chef is in the kitchen and I am in the restaurant eating. A waiter goes and brings the food from the chef and brings it to me. That's what an API do. An API is like a middle guy who makes sure that when you use a particular service, everything works well. So the point is that is a technical feature, but you, as a data scientist, you can't worry only about APIs. You have to worry about KPIs. KPI is more of a business context. So in a nutshell, what I'm trying to say here is a good developer or a suboptimal data scientist is one who's just worried about the tech and the tech and the tech, but doesn't recognize that there's a business behind all of this, right? So all API, no KPI. KPI is key performance indicators. And so that is a business indicator. So a good data scientist, in a nutshell, should be familiar with the business. You have to understand the business first of all. And by business, I don't necessarily mean entrepreneurship. It could be a government agency. It could be whatever you're doing. But you have to understand that context in which you're working before you can deliver value from a technical side, because other than that, you won't be able to do that. Also, another feature of a suboptimal data scientist is optimizing that which should never be optimized. And again, this also ties in with point number one, because you don't understand the business. And so you don't know, for you, everything, oh, let's automate everything, right? Let's make life easy. But you fail to understand that there are some things that should be inherently human-driven. And there are some things that we can automate. Not everything that can be automated should be automated. For example, in the area of research, right, there may be some things that the human being needs to do. For example, a human being needs to come up with the title of a project. A human being should conduct certain aspects of analysis. There's some key tasks that are inherently human. Now, can they be automated? Yes. Should we automate them? Well, no, because that doesn't necessarily align with ethical conduct of research. And so this is why data scientists must understand the field in which they're operating. They have to understand that, well, not everything that can be automated should be automated. And so optimizing that which should never be optimized is one of the things that would indicate that you are a bit naive or you're not experienced in the context in which you're working. Lack of quality assurance or adequate testing. Okay, you write code and you somehow just push this code without like testing it. Like, you really have a lot of trust and faith in yourself. And so test. Again, this goes back to my earlier point about paranoia. You need to be paranoid that you made a mistake. And that is what drives you to test and test and test again. Poor documentation. That is such a terrible thing, because even you yourself, if you come back to your code, the code you wrote 2 months later, or 4 months later, you start wondering, I wonder what this was all about, And then we also recall that you are working in a collaborative environment, right? And so if you are part of a team, somebody else, you might be away from work, maybe you're sick or you traveled, somebody else might need to deploy your code. And so It is a failure of a system when we need you to be there for us to understand your code. That means that all our systems have failed. So if you're a data scientist and we have to pick our phone and call you and say, hey, this code you wrote online, 122, what is it saying? Or can you jump on a call? That means that there is a complete failure of systems. There's a failure of documentation. That's a bad thing. It is a business risk as well, because it means that our systems are not sustainable. The business is not sustainable. We need you to be physically there. So poor documentation is a hallmark of a poor data scientist. Trying to be a hero. What do I mean by that? It means that you should know your limitations. When you struggle with a problem and you've come to a point where you're like, okay, I am completely out of my depth, you should be able to know when to call for help. And this is something I tell my engineers all the time. Please, we're a bunch of pretty smart people here. If you reach your depth, just shout, all right? And someone will help you. So don't try to be a hero. Know when to call for help. At the same time, the reverse of that also makes you a horrible, data scientist. If you need a babysitter all the time, that you come to an organization and every single thing somebody has to literally explain, like every single thing for you, like you're unable to independently work. And even after things have been explained to you, somebody has to come back and review your work over and over and over, because it's maybe you're in the wrong profession. So if you constantly need that kind of hand holding, maybe perhaps you're in the wrong profession. You're not data science. You may love data science, but data science does not love you back. Then what I call the monkey and the banana problem. When a monkey grabs hold of a banana, it's almost impossible to separate it from that banana. So while I said earlier that you should be obsessed about the problem, you should also know when the problem is not solvable, right? If you and this is something we've experienced, right? Where we're like, okay, we've solved this, we've put our best effort to solving this problem. At this point, we can conclude that this problem is simply unsolvable because the technology has not reached to that point yet where we can solve it. So we'll just put it on the side burner and come back to that later. Please do not push for easy solutions as opposed to optimal solutions. Of course, optimal solutions will take more time, will take more effort, will take more just thinking through the problem and collaborating. So don't be in a rush to go for what is easy, right? At the same time, don't push for the perfect solutions. That's what we call it optimal. Optimal means it's just good enough. It's not perfect and it's not horrible. It's optimal. So optimal doesn't mean perfect. So we don't need to have the perfect solution to have a good solution, right? We don't want the perfect to become the enemy of the good. Do not be too quick to say no or to say that something is impossible. Now, that is something that really, really irritates me. Like, saying that something is impossible is a real statement of arrogance, because somehow you assume that because it's impossible for you, it's impossible for everybody else. So don't be too quick to say no. I don't want my engineer to come and tell me that no, this is hard or this is impossible. No, that is unacceptable to me. Tell me why it is hard and what the trade-offs are and how we can address it. And then we can quantify the risks. We can quantify whether the juice is worth the squeeze. And then we can decide whether it's a go or no go. But just declaring that something is impossible, for me, it indicates that you have a complete lack of imagination. And, and that's not a good thing. You also should not be caught up in the new shiny object. There are always new technologies coming out, new frameworks, new ways of doing things, new software. Like, let's not go around chasing the newest thing on the block, right? Let's stick with the principles and let's solve problems. And then at the end of the day, it doesn't really matter whether you're the smartest guy in the whole world, right? You have great aptitude, but poor attitude, that is not going to work. You should have to work with people, right? So those are some characteristics that will make you a suboptimal data scientist, and you want to stay away from those. Data scientist could be an entrepreneur or an intrapreneur. So you don't have to own your own business. Even within an agency or a company that you are employed as an employee, obviously, you can still solve problems. Theodore Levi says that, creativity is thinking up new things. Innovation is doing new things. So data science or data scientist is someone who can truly bring about change in the way we do things. One of my favorite pursuits is the pursuit of seamlessness. I think about seamlessness a lot in the work I do, and how can we deliver an experience that is just wow? How do you elicit the wow factor, right? A seam is simply where two materials come about and are joined together by like a stitch. So these are seams and these are stitches that join two seams, right? When you think of it as something that is seamless, there are no. Look at this table tennis egg. There's no seam. You can't see where something begins or where it ends, right? And so, as a data scientist, right, that's something that you need to think about all the time. Like in the context of improving things, because remember we said that a statistician tries to prove, while a data scientist should try to improve things. How can we bring about improvements in processes in such a way that it appears to be seamless, right, to the user? So that should be the goal. And so that reflects in how you do things, how you build your solutions, and how you even think about solutions in general. So what does it take to build a solution as a data scientist? Because if you're a data scientist at some point, you have to build a solution, you have to build a process, something that works, right? So it's 3 steps simply, right? Can I get it to work on my machine? So it should at least work on my computer, right? Now that's step 1, check. Can I integrate it with the rest of a solution? The fact that it works on your computer does not mean it's going to work in the solution, because now you have to integrate it with everything that is existing. And so that's the second check. And then number 3, can I scale it? Scalability is extremely important in your work as a data scientist. The fact that it works for 10,000 people doesn't mean that it's going to work for 10 million people. It might break because you did not build it in a way that it will scale, right? And so for any solution you're doing, right, those are the 3 ways or 3 steps you want to think about. First of all, I just want to solve a problem. Like, let me just figure out the solution, and let me write the code and make sure that this solution solves this problem on my computer. And I'm okay, great. Then I can then integrate it into the solution, and then we can now figure out, okay, what kinds of technologies can we incorporate, or what kind of frameworks can we inculcate into the solution in such a way that it will scale. And that might mean changing the language, right? Some languages are more scalable than others, all right? R, for example, is notoriously non-scalable, and so if I want to build a data solution that is very scalable, then I might say, maybe I don't want to use R, for example. Maybe I want to use Rust, for example, because then it's more scalable. But again, before I get to that part, you have to worry about making sure it works and it integrates, and then issues of scalability can come later. A good data scientist, you should be able to take a big problem and break it down into its component parts. Like I say, how do you eat an elephant? Well, 1 bite at a time. So how do we take a huge complex problem and divide it into small parts? This is how you must think as a data scientist, right? I have a huge problem. I want to solve this XYZ problem. Very complicated. Okay. How do I break that? Why can't I solve that problem? Well, let me write down all the reasons why I cannot solve that problem. Well, number 1, to solve this problem, I must be able to do X, Y, Z. Then I must be able to do X, Y, A, B, C. Then I must do this. Then I must do that. So if I do all of these things, that means I can solve that problem. And then I can now start taking each of those things one by one and solving them. So the ability to split, apply, combine. Take a big problem, split it into small parts, solve each part, and put them together. So this is what we mean by problem solving. If you cannot take a problem and split it into small parts, then most likely you won't be able to solve the problem. And this is where code comes in, right? We said earlier that, well, being a data scientist is not all about writing code, but it's what I call the finger of God. Like code is one of the most it is the magic of today. There's a thin line between code and magic nowadays, because all of the things that code can achieve now, Well, a few centuries ago, that would have been described as magic. Like imagine what we're doing now. Right? We're speaking over Zoom. You can see this. These slides are on my screen, and you are all over around the world, and you can see my screen and you can hear me in real time. This is code working, right? Automating tasks, predicting the future. We can, fit predictive models. We can do sentiment analysis to know what people think. These are just the marvels of code, right? So, fine, we said it's not all about writing code, but that sentence will be incomplete if we do not say that a huge part of being a data scientist is also about writing good code. And so, now, since the session is about R, what are some of the minimum requirements that you need to have to call yourself a data scientist, based on the R programming language? First and most important, you need to have a deep understanding of data structures. I cannot emphasize, if that's the only thing you know, that's fine, but you need to deeply understand data structures, lists, data frame, vectors, scalars, so on and so forth. Because every solution you're going to create will come out as one kind of data structure or another. So if I'm creating a solution, do I want to render the solution as a data frame or as a list or as a vector or as what? Like, if you don't even understand data structures, how then are you going to be able to take in a particular piece of information, process it, and deliver it as an output in an appropriate form? So again, like I said, if there was one skill I would emphasize, that if there's just one thing you have to learn, that would be a deep, and I emphasize the word deep understanding of data structures. You also have to intuitively understand logic. So that means that logic has to be your second nature. You have to understand that, because if you cannot understand logic, you cannot build solutions. Again, remember that our emphasis now is not just to write a logistic regression analysis that would give us predictors of smoking. No, we're talking about building solutions as a data scientist, right? You need to have an intuitive understanding of logic. You have to be able to write good functions. A function is like a tool, a small tool you are building to do a particular task. You can't just be copying and pasting code, right? So that's why we write functions. So you need to write functions, good functions, and to be able to validate them appropriately. Perhaps maybe in the future session, we're going to have on a deeper dive into R, where we'll just talk about how do you write a good function. But for today, again, today's session is not to teach you about writing code. It's the fundamentals of what we mean by good data scientist. Now, you don't have to write every function yourself. There are some functions that have been written already and are in packages for data manipulation, data cleaning, data visualization. Those are abundant in R, and you can use any of them. You need to be familiar with machine learning algorithms, and there are also packages in R that do that excellently, right? Like the MLR package and the Caret package in R that allow you to implement machine learning algorithms. And then, not to be overlooked, you need to have a strong grasp of statistics. Remember that a data scientist is partly a statistician, right? He has some skills from the world of statistics. So you can't call yourself a data scientist if you have zero ideas about the world of statistics. You need to have a strong grasp of statistical methods and techniques, including hypothesis testing, regression analysis, and Bayesian statistics, right? So those are, in my judgment, the minimum requirements for you to declare yourself as a data scientist, whether it's R or whatever. Now, we're going to also talk about data science without talking about AI. I mean, the world is crazy on AI. And there are a huge number of tools. How do you use AI in your work as a data scientist? This picture is a good rendition of how AI is being used today in many software applications. It's like, okay, sure, we'll pour it into the bowl, but now let's just pour it everywhere, right? There's excessive use of AI. Even in areas where AI should not be used, right? So it almost feels as though there's a need to just use AI just copiously and just extra everywhere. So a good data scientist, you should know when to use a particular technology and when it's okay, it has served its purpose and we should we should do something else. So this is what I call the task hierarchy in terms of AI usage. You should know intuitively what kind of tasks AI will be appropriate for and the ones that AI will not be able to handle very well. And so if we look at them in 3 tiers, tier 1 is just correct work, right? If I have a bunch of unstructured data with emails, and I just want to extract the emails into one column, oh, AI can do that excellently well. I can just say, hey, extract the emails and put them to me as structured data in one column. It will do that 10 times out of 10 times, it will do that excellently well. That's correct work. Tier 2 work is work that is just good enough. If I tell AI, okay, summarize this text, I have this, this bunch of paragraphs. I want you to summarize them for me. Well, the work may not be the work that will meet the standards of a Nobel laureate, but the summary is good enough for me, right? So that's just good enough work. But then you have certain work that AI should not be, as a good data scientist, you should know that AI should not be doing this, right? I should not even ask AI to do it, And so at Chisquares, for example, our policy, our framework is based on, a risk-based framework, right? We use AI as glue. So AI as glue, meaning that we just use AI to make certain tasks seamless. So Mao said, talk about seamlessness there. Seamlessness is the perception of seamlessness, where it almost seems as if the processes are just so fluid and so coherent. It's like, wow, this is such a nice experience. So what glues those different processes together is AI. So we use AI to just make life so easy, so that you don't feel the pressure, feel the burdenness of the task. But in doing so, we also look at the risk-based framework. And that essentially says that we classify all tasks as either high-risk tasks or low-risk. A high-risk task is anything that has to do with data, and any type of data for that matter, right? If we are dealing with bibliographic data or your data set or any kind of data for that matter, as far as it's something that we're going to analyze to make an inference, AI cannot touch that, right? Because that is a high-risk task. We can use AI for any other thing, summarize text. We say, okay, take this big text and make it small, or take this small text and make it big. Those are low-risk tasks. And so those are, again, a good data scientist should have an awareness of why we have that framework in place, and and the risks of using AI for things that can be considered as tasks that it cannot, at least at this time, do excellently well. Okay, I'm sure you all know what ChatGPT is. So what I want to do now is to walk you through so that you can see how all of these tasks come together. Walk you through the process of, let's say, designing a simple survey. But now, instead of just worrying about the science, right, we want to pay particular attention to the data tasks on the platform. And so you can see how data science plays such a key role in building technology, right? Well, of course, it's a teamwork, but like we said, the data scientist is a core part of that team. So what I want to do now is to we'll go through the process of creating a simple survey. And as we go from one process to the other, we can appreciate the tasks involved, the data tasks involved, so that tomorrow, what we could then do is we'll build on that. We could say, okay, here is what we've done today. Now, what does it take to actually build something like that, right? So you've seen that, okay, you click, sometimes users actually do not understand the complexity of the solution, right? You just click something and things happen and you don't really understand just the complexity that goes into that. So tomorrow and next, we're actually going to dive into code to see, all right, so what goes on behind the scenes when you click on this and X, Y, or Z happens, right? How do you build the code? How do you even think through the problems? But for now, we want to go through that process of reviewing the work so that we can see how knowledge of data structures ties into the different things we've just talked about. So you can see from a first-hand experience how that works and how that ties in together. But before I do that, I'm going to stop now and see if there are any questions. Lungi, are there any questions?
Yes.
Okay.
Someone wanted to ask a question. Lloyd? Lloyd, are you still here? Okay. Okay. Someone also asked, what of those only interested in using the packages to analyze the data?
That's fine too. But in the focus of this presentation is not necessarily for we're not this wasn't geared at data analysis, data analysts or statisticians. The topic was specifically about data scientists, and that's why we are focusing on data science. But if you're just interested in analyzing the data, making inferences, that is completely fine too. So you don't have to go all the way,
Okay. You can unmute yourself, Lloyd.
Okay, thank you very much. Good evening to everyone
Hi.
else in the group, and good day, Doctor. So I just wanted to understand. There's a point you made in the beginning of the presentation. You spoke about not being a hero, and at the same time, you shouldn't need a babysitter. So I just wanted you to just put some more emphasis, because I believe the line between the two is a bit thin. Given the fact that in computer science, it's especially data science, it's an evolving paradigm where things are always happening. So then, how do you know when you actually do need help and when you actually need to push yourself to fully understand and grasp certain concepts?
That's a very good question. I really love that question. So let's take two data scientists, right? I have two, junior engineers, on the team. I give them tasks. One, and they come back to me. The first thing I'm going to ask is, so let me see what you've done so far. Let me see let me see your code, right? Let's review your code and let's see what you've done. And so this is 2 weeks after I give them both of them their tasks, right? The first guy is like, oh, I didn't write any code. Like, I don't have anything. I just wanted to have another meeting with you so that you can explain to me everything you explained that first time. Oh, really? Like, you are as lazy as the calm. So you mean that 2 weeks you did not write one line of code. You did not think about the problem. Like, you did nothing, right? The other person comes and says, okay, here are the notes I made. I attempted the code. Here, can we have a code review? This is where I was stuck online. As you can see from line 142 of my code, I'm not sure, why this stuff is not returning this, or why. See, this person has made efforts, right? So what I'm saying is that please do not come back to me and say, just explain to me all you explained before, right? I need to see some evidence that you have worked. And of course, I'm going to know if you just went and copied some ChatGPT code and just to give an appearance of work, right? I need to know that you have thought through the problem and that you've reached a block where you can't proceed. And so I have enough expertise to determine that, wow, you've really tried your best, right? So a babysitter is one who's just either just intellectually just non-curious or just lazy, or a combination of those, and not willing to exert themselves, right? And so just need somebody to hold them by the hand for every step of the way. Whereas somebody who is genuinely trying, I don't want them to spend all the. If you reach a point where you know you cannot progress, I want you to try to learn, right? So learn how to learn, but don't let it take forever. If it's 1 day past, 2 days past, and you're still stuck, it's time for you to scream or to shout and say, hey, I need help. I hope that is clear. It's a fine distinction, like you said. but there is a distinction there.
Thank you very much.
Is this course going to teach data cleaning and data analysis to help in writing manuscripts?
No, we're not going into the rubrics of data cleaning and data analysis. We're going to talk about code writing tomorrow. But the goal of the course, I think that was actually on the flyer, it's like we're not going to the rubrics of saying, hey, this is how you write hello world, right? It's going to be on a high level. So even when we talk about code tomorrow or next, it's going to be at a very high level. So this session is really for those who really want to understand the principles, right? And so the things that we will talk about, of course, are applicable to data cleaning and analysis. But if your goal is to attend the session so that you can learn how to do the nitty-gritty of your cleaning, this session will not help you. Again, it's focused on broad, high-level principles of things you need to know as a data scientist.
Do you have, oh, okay. So this is the same question. Okay. If I understood correctly, the job of a data scientist is to know which model best serves the data in order to predict accurately and how to make good examples.
The work of the data scientist is this is day-to-day task of what you'll be doing as data scientist: data cleaning and preparation, exploratory analysis, engineering features, testing features, documenting code, collaborating with people again. So those are the things you're going to be doing. The issues of regression and deep learning, of course, those are, of course, you might do them, but they're not going to be day-to-day tasks. And of course, depends on the organization you're working in too, right? In Chisquares, these are the day-to-day tasks of, you spend a lot of time on feature engineering, like just building a feature, right? We want to build a feature that the user can upload their whatever in so and so form, right? Well, it's your job as a data scientist to go and figure that out. That is feature engineering. So, and again, like I said, it's going to vary from organization to organization because data science is a very amorphous field.
Are you going to cover the syntax of R in the upcoming session today or tomorrow?
Tomorrow, we're going to do a little bit. Again, we're not going to go to the ABC of R and say, hey, this is how you write. We'll cover a little of it, but it's not going to be in depth. So if you've never read written code in R, you will have to go and learn, a whole bunch of that by yourself. But we're going to provide you with a high level understanding of how it works.
I think, yeah. What's the specific target for the next 2 days? Deep learning, visualization, etc.
So we're going, again, like I said, we're focusing on the principles, right? So tomorrow we're going to talk about a gentle introduction to R and some of the basic libraries that folks. Again, if you're interested in the nuances of, if you're coming to this session with the ability that, wow, when I leave this session, I'll be able to learn, do machine learning tasks, or I'm going to be able to perfectly clean my data. This is not the session for you. Like we said in the flyer, this is focused on high-level principles. So just to share that in all transparency so that you don't waste your time, if that is what you are looking for, that this will not be the session for you. The next 2 days, we're going to focus on high principles, the same way we've covered the session, but tomorrow and next, we'll focus on the code and the syntax, but again, from a very high level.
Okay, similar question. What are the coverage areas of this data scientist that we're going to cover? ANOVA chi-square, correlation, and regression. Will we continue with the same time slots? Should we install R for coding to complete the task given in the coming classes?
You can install R for sure. I can, but the tasks, I can again, we're going to review them tomorrow. How about you just show up tomorrow and just see what, because we're gonna go by, go play by ear. So, I would rather save the time so that we can cover what we're supposed to cover today than talking about what we might cover tomorrow or not. Those have been already covered in the syllabus. So please refer to the syllabus.
Okay.
So
Any other questions?
In principle, again, let me just emphasize. So folks, those who want to learn, who this is what they want to learn can show up, and those who this is tangential to what they want can choose not to come. You're not going to come and leave away with, wow, I never knew how to write code in R, and now I'm an expert in R. That is never going to happen. So we're going to cover some code, but it's going to be at a high level. So that is what you should keep in mind when you're coming tomorrow. So that should inform whether you choose to come or not.
Okay, so when do you plan to teach data analysis?
You're gonna well, just follow us on LinkedIn. We had an 8-week course on R where we covered the fundamentals of R and the ABCs of R. So I assume that you were not in that session. So we might have another session like that. So just follow us on LinkedIn. We don't know yet, but when we post that, you can follow us in real time and you'll be the first to know. But we'll have that session again. That was a different session that was focused on you don't know anything in R. How do we teach you how, at the end of this 8 weeks, you should become proficient in R? This is not that session.
I'm afraid to ask the same question,
Then
but I'll ask anyway. Are we going to learn Shiny, Quarto, or R Markdown too?
No, you will not learn that. You can go to YouTube and learn those things. Like the principles I'm talking about are things that are high-level principles that you may not easily learn on YouTube. And the things that you are asking are things that you can learn. The golden rule is do not do for others what they are perfectly capable of doing for themselves. So we're not going to cover all of those things you're asking. It's again, principles. Any other questions?
No.
All right, great. All right, so now let's go back to the Chisquares platform and let's see. Again, as we go through the task, we'll see how you can see how data science is applied, and that provides you with some context for what we are doing. Lingla, do you remember how to get rid of these lines?
Yes, you need to stop sharing and reshare.
Okay, already.
Mario,
all right, so
Jeremiah, you have a question? Sorry, I didn't see your hand. Okay, you can ask later. Tatsagaku, you can continue.
All right, so this is the Chisquares platform. For those who are not familiar with the Chisquares platform, it's a one-stop shop for everything that is research. So on Chisquares, you can come design your studies, calculate sample size, collect data, like launch your surveys. The platform also analyzes the data for you and all of that. But what we really want to go through is to just go through a simple process of creating a survey. And we want to pay very close attention to see how data science is leveraged in real applications. So that what we just said shouldn't sound so abstract to you. It should sound, like you should have a context for how it works. So let me log in. And let's start a survey. So on the Chisquares platform, to start a survey, you come to survey design, and I'll start a new survey. So let's say that we want to do a survey that looks at evaluation, right? Evaluation of the our workshop on data science. The participants, we don't have a predefined location, so we can leave that blank. The aims of a study, again, every research paper, whether it's a research manuscript or a thesis or a dissertation or a grant, should have aims. Now, we'll now come to the first application of data science. How do we help people? Because remember, this goes back to the issue of seamlessness. The experience should be seamless. So I am a novice in research. I want to collect data. Let's say this is for a grant, and I don't know how to write aims. Again, so we come to the first application of data science. Data scientist, in this case, was responsible for taking this information, the context what the user has provided, and integrating that with AI and providing us with the suggestions here. So now you see you have aims that have been suggested for you by the platform seamlessly. Again, we'll go back to that word, it's having a seamless experience. So I can say, okay, these are the aims that I want. And again, you also see immediately the issues of data structure. How are we going to render the data to the user? So like, what kind of data structure is this? Because this is data. So how has the data been rendered, right? Those are the decisions that the data scientists had to take. Like, how would the data go out? Because this, how will the data go out and how will it come back in, right? What's the best way to present the data that makes sense, that makes a seamless experience? So you can see right off the bat, we see a first application of data science. So selected our aims and clear the remaining ones. The same thing for keywords, right? Again, having a seamless experience. The user might not know what keywords are. The platform suggests it to them. Again, a direct application of data science. So we start our project. So just in page 1 already, you see that we already have applications of data science in real time. For now, this is a collaborative platform. You can invite collaborators, but for now, let's keep that for now. And let us go to our survey where we can create questions and we can see, again, other direct applications of data science. So now let's create a couple of questions. There are 5 ways to create questions on the platform. You can start from a blank survey. You can copy an existing survey, in which case, it shows you all the surveys that exist, and you can copy one that you want. You have an option to import from survey bank, to import from Word. Now, when you import a questionnaire from Word, let us see again how that is a direct application of data science. Let me see if I can pull up a questionnaire that has, so this is the format of a questionnaire that's imported from Word. Yeah, you have to put some formatting. So imagine you are a data scientist, right, in Chisquares, and they said, okay, please go and figure out how do we import a questionnaire in Microsoft Word, right? It's now your job to figure out how, like, okay, what kind of data is this? This data we have right now, like, it is obviously unstructured. How do I take this unstructured data and convert it into a form that is structured? So you see, this is not just like, okay, we want to do this. You have to now go into the weeds of how am I going to make this happen? For you to achieve that, you must have a solid understanding of data structures. And so you now have to figure out, okay, what kind of data structure do I even want to work with? Is it a list? Is it a data frame? Is it a vector? So again, this just goes back to emphasize that you cannot do the data science if you don't have an understanding of data structures and how they work, right? Because you will need that as either inputs or outputs of your work. So this is import from Word. For tomorrow's exercise, we don't have import from Excel. And that is what we're going to solve for our task tomorrow, since a lot of you were asking. So tomorrow we're going to say, okay, we only have import from Word. And this is how the import from Word is. And let's say we don't like all these features. We don't have the time to be saying at A and this, right? How do you then, if you were now tasked with the work of, okay, go and build a feature that can import from Excel? How do you even start thinking about that, right? And so that's what we're going to cover tomorrow tomorrow and the next day. We're going to talk about thinking through the problem and how do you write the code and how do you structure it and all of those things in R. So that's going to be the session tomorrow and next. So for those of you who are so curious, that's what we're going to cover. And then use AI Builder. Again, Using AI Builder, you specify the number of questions you want, and you click on generate. See, the experience itself feels seamless, right? Because all the user is doing is select number of questions and click generate. But there is a lot of data science that is going on behind the background, right? So you have your questions here. You can just select the ones you want, right? And you just import them. But behind all of that, there's a lot of a lot of data science involved in that whole process. Like, how do we, for example, if you look at ChatGPT, the output from ChatGPT, it is unstructured. So how do we take it from unstructured and make it something structured, right? And then if the user selects something that is wrong, how do we display validation errors so that they know that they did not make a right selection, right? So those are all of some of the things that are required when we talk about, data science. So you can see the direct applications of that in everywhere you do, or whatever you do on the platform. Now, let's go and say we want to start a blank survey. And let's just add 1 or 2 questions to our survey. Let's say, what is your background, educational background? And so here, the user is supposed to type a label, and that label later becomes a variable name, right? And so to provide a seamless experience, we say, okay, this user may not know what a label is. So let's give them suggestions. The user clicks on get suggestions, and the platform then suggests, some labels that they can use. They can click again, and it supplies more. Again, this simple task here, there is obviously AI involvement here. So if you're a data scientist, how do you make that happen? So again, I'm just trying to show you specific examples so that you can see the kind of tasks that data scientists do and how you have to think about problems. Because obviously, if I give you a problem to solve, I'm not going to give you the solution. You have to bring the solution to me, and then we can figure out which solution is the best, right? So those are some of the things that you have to think about as a data scientist. Let's say here you said, your educational background is in, let's say, nursing, engineering, and let's just say other specialty. Right, and then we can then push the questionnaire. And then let's add 1 more question to our survey. Let's say, what country are you from? Select that, and let's use system supply text. And then we'll push questionnaire. So again, we've seen how AI is involved in that and the role of data scientists there. But there are also other features, right, that involve data science. Remember, our goal is to provide a seamless experience for participants. So what if somebody wants to translate their survey into other languages, right? What is the role of a data scientist in that process? In this case, if I want to translate my survey to, let's say, French, I simply select the language I want. Now, I now have to enter the translations here. But what I want to challenge you is that when you do this kind of process, when you click and something happens, you have to wonder, if I were the data scientist, how would I engineer this feature? Like, how will I do the same? Will I do it differently? You have to be curious about, okay, how does this? So I just click on, let's say, this button here, and it analyzes, it translates the text, right? How is that happening, right? Those are the kinds of things that, if you're a data scientist, you will be doing, right? Because it's about, okay, we want to solve a problem, and we want to do it in a way that is seamless, that makes life easy for the individual. And so those are, again, things that the data scientist does, and things that you have to be thinking about, so that when you are in that situation, you will also be able to solve those problems seamlessly. Because the whole point is to solve a problem and make life easy for the user. So now I've translated my survey, and I want to launch it. So let's launch a survey and let's look at how the field of data science is also used in other areas, like in analyzing data, for example, in writing reports automatically, right? And again, the goal is for you to think through those problems, or this, so that tomorrow when we are going through the problem we're trying to solve, you can at least bring alternatives and say, okay, could we do this way, or could we do it that way? So our survey is available in English and in French now. So let's go ahead and launch our survey, and let us see how data science is also used in other domains as well. So let's set our dates and timelines. So let's launch that, and let's get some responses so that we can then see how, let me complete one or two responses. All right, let me share the link so that we have some responses. And so if you can take the survey, please take it so that we can generate some responses, and then we can see how, again, data science is used in other areas, such as, again, the whole goal is how do we make the user's life easy? How do we solve their problems for them in a way that is seamless, right? That is the framework against which we operate. So, and data science is just a tool for us to achieve those objectives. So okay, so we have 4 responses now. Now we can download the methodology report. Again, that is also a direct function of data science. Like, okay, we want to have a methodology report that documents how the study was conducted, and issues of person, place, and time. So we want the user's life to be so easy that everything is just one click, like one-click solutions. The user doesn't have, it's our job to suffer as the ones creating a solution. The user doesn't care that the solution is complex. All the user wants is a solution, and so the user, with just one click, they want the whole report to be generated for them so that they can access it and use it for their work, right? It is our jobs as data scientists and members of a team to then figure out how best to do that in a way that is seamless. So you see, this is our report that has been generated in seconds. So my question to you is, if you were a data scientist, how will you frame this? Because it is not as if this report was sitting down somewhere, or some parts of it were sitting down somewhere that we just grabbed and chunked it into this report. This was written in real time, in seconds, right? And it talks about everything that we need: the background, the study design, the study's participants, the administration of the survey, the limitations, and so on and so forth, right? It is a complete report for the study. So how do you do that? Again, this goes back to what I was saying earlier about being curious about how things work, right? And you need to ask yourself, if I was the one doing this, how will I do it? And then you have to go beyond that. You have to say, okay, my mock project will be to write a report like this, so that it's automated. And so those are going to be your first tasks to really challenge yourself. Like, I'm going to write an automated report, study report, that is going to be dynamic, in real time, and delivered in seconds. And that's how you gain, expertise in the field. And so, of course, this also uses, the AI is involved in some parts to write the background for the user. So it's a mix of AI and just, rules-based programming. The same thing with the analysis report. If I wanted to download the analysis report, again, just a single click. It takes the data, analyzes the data. But again, based on our framework, we do not use AI for anything that involves data, right? So the question is, what you should be thinking is then, how does it do that? Like, how do you engineer a solution that would just in seconds, it takes the data, it knows the kind of data it is, it analyzes appropriately, it creates the figures, right? So that the user can then take that report, and again, everything is done in seconds, and without the use of AI, because based on our risk-based framework, we cannot use AI for that. So you can see the diversity of areas between the time we started the project, and now you can just see all the areas AI, data science is involved obviously in collaboration with all the other members of the team, right? Engineering team. Because for us to be able to see this, the designer had to design this thing, obviously. The data we're analyzing comes from the back end. The back end has to, that we can click on download and it downloads. Of course, that's the front end, right? But it's a team approach. But the data scientist is a core part of that team and makes the whole production come to life. So, so keep this in mind. Tomorrow, when we're talking about our solution, and you can start thinking of, okay, how can we do this? Like, because there's no one way to do one thing, right? There are many, many, many ways. We have to think through the ways and then figure out the one that makes the most sense. Either it's just efficient in terms of computing power, or in terms of cost, or in terms of other parameters, But you have to come up with solutions, because at the end of the day, it's just a human being that has to write the code, right? And that is your job as the scientist. So again, I want to emphasize, these sessions are for people who, this is a data science workshop. It's not for statistics, and that's why the focus is more on data science. In case you're wondering, oh, I just want to clean my data and generate p-values. The goal of this session is on primarily focus on data science, and that's why we're going into that slant. Any questions? I'm going to stop there and take questions if there are any. Lungi, do you have any questions for me?
Checking, not yet. Okay, thanks, Ilya, for answering. Can a master student use the Chisquares for data collection and analysis at master's level, most especially in epidemiology, apart from SPSS that's highly recognized?
Yeah, of course you can use you can use the platform for your data collection, and for those attendants, and long as you can share with them we provide free access to the platform for people who attend our session so they can use it for your work. So Lungile will share the link with you so that you can, if you're doing any data collection, the best thing that could happen to you is using the Chisquares platform, really, because there is nothing that involves data collection that has not been very, very carefully thought out in terms of validity and reproducibility and documentation and collaboration, right? It's a collaborative environment. And so, so it is literally the best thing that will happen to you if you're collecting data and you've not really started, because again, all of those considerations have been very, very carefully put into place so that the data you get are fit for use and fit for purpose as well. If you're doing work along the lines of research, the platform also does all the work of cleaning your data set for you automatically. So you can download the raw data, or you can access the already cleaned data set. So for those of you who are asking about, are we going to teach about data cleaning? Well, if you're using the Chisquares platform, you don't have to worry about that because all of the data are automatically cleaned for you. Of course, if you want to suffer, you can download the raw data set and clean it yourself. But the platform automatically cleans the data for you as well.
Okay. So, before we continue, I've shared a survey. I've shared a link, and I would like everyone to complete, especially those who would like to receive certificates of attendance. I'm going to share it again. Here it is. So basically, it's an evaluation survey. So we would like to know your thoughts about the session, but most importantly, we would need your email addresses if you want to receive a certificate. So please complete the survey. If you only want to complete just your name and email address, that's fine too. You're not forced to respond to all the questions, but we would like to get some feedback. Thanks. Okay. So yeah, I will share the link in a second. I just wanted to first start with this evaluation before people leave. Other questions? Okay, we have Dr. Asunda Chagwa. You can unmute yourself.
Okay, good afternoon, good evening, good morning. Please, I just want to ask, how can I use Chi-Square in veterinary profession? That is, we are doing vaccination, we are treating animals, we are going out for outbreak investigation, that's outbreak in animals, so that it will not cross to human being. So how
Okay.
can I use Square in this scenario of patient?
Okay, so what you could do then is you can, let's pause the survey now. What you do is you can use the Chisquares platform for any kind of data collection, right? But in the case of the outbreak you described, obviously you are the one who will be collecting the data on all the animals. So you have, for each animal, you might have different indicators, like you have the temperature, you have, whether they have, certain characteristics or not. So you'd come to settings, and then you come to the option that says multiple entries. You say, yes, allow multiple submissions, and then you save, so that when you take the survey this time around, when you go to preview and you start taking the survey, at the end of a survey, it says submit another response. So you are the one who is just submitting a response for the different animals over and over and over again. So that's how you can do it. Does that make sense?
Sorry, Doctor, can you repeat that? Sorry.
Yes.
Can you repeat that?
Okay. I said you go to the settings and you go to multiple entries. Multiple entries means suggests that you are the one who is collecting the data for all the people. So you want to be able to submit one form and then submit another form, so on and so forth. By default, it says no, restrict to one submission per individual. But if that's your case, you can say yes, allow multiple submissions, so that when you're taking the survey, right, it would allow you start the survey, you complete the responses, and once you've submitted, you see it says submit another response. If I click on this, it takes me again to the form, and then I can start, I can submit over and over and over for all the subjects in my study.
Lloyd?
Sorry, my network went off, so I couldn't hear the answer from my question. My network went off. Sorry,
okay.
If Doctor should repeat it.
Sure, I can repeat it again. So I said that you go to settings. By default, you're only allowed to submit one. You have one answer per participant. But in this case, you are the one who is filling the responses for all the animals. So in that case, you say, yes, allow multiple submissions under the settings. And what happens is that once you take the survey, if you resume this, if we took a survey, let me copy the link again. And we took the survey. So let's say this is the first animal. I complete their response for them, and I submit. Here now I have this field, that this button that was not there before. Submit another response. I can now do it for the second animal. And provide and submit again, and then continue like that over and over and over. So that's how you would do it if you are collecting animal for a population that cannot answer for itself, because you are the one who is recording the responses. Does that make sense?
Okay, yeah, it makes sense.
All right, great.
So, but this one, is it for treatment or outbreak investigation or vaccination?
It doesn't matter whatever data you're collecting. It could be any data.
Okay. Okay.
Okay, Lloyd, do you have a question or is that by mistake?
Yes, I do. Forgive me for the question I'm going to ask. It's a bit condescending in my part, but it's my first time hearing about Chi-Squares. So it's a very good website. Can you just give me an overview of what you guys do, like what you guys
Okay.
specialize in, and do you guys also give public data sets?
Okay. Yeah. So okay. Sorry. Go ahead. Sorry, I
and-
interrupted you. I thought you were done. Go ahead.
Also, and then if you do, are they based like African data sets, South Africa, depending on location? Yeah, I think I'm done.
Okay. Thank you. So Chisquares is we're a tech firm, a tech company, which specializes in research, right? So it's a platform for researchers by researchers, but it's not just for research. You can collect any kind of data. Chisquares aims to be a one-stop shop for everything that is related to research. So that means that you can design your studies. You can, let's say you are a master's student who has no idea what to do for their research. You can come to Chisquares and go to our survey bank and you explore to see the possible topics that you could work on. And if you go to research survey, you could then select the area of your area of interest. Let's say I'm interested in chronic diseases. I can say, okay, I just want chronic disease topics. And I see all the surveys there. I can say, oh, I'm interested in online health information and the impact on lifestyle choices. So you have questions that I can then choose to copy the entire survey for my work, right? I can just say, oh, copy this entire survey and use it for my research. So Chi-Squares has thousands of questions and surveys. And the whole idea is based on the principle of open science that we can share, right? This is a survey I just copied now. And so I can then use that for my thesis. So that's what the survey bank does. So in the survey bank, you can explore and use, but you can also contribute. When you contribute questions to the bank, they go through a vetting process to make sure that the questions are valid scientifically and that they are not offensive and there is no bias in how the questions were framed. You can also calculate sample size. If you're writing a study or if you're doing a grant application, obviously you need to calculate sample size. So to calculate sample size, you come here. The platform supports almost every single kind of epidemiologic study that you would want to perform, from observational studies to experimental designs and everything in between. So if I was doing, for example, a survey of, let's say, Ghana, I provide the inputs and the platform does not assume knowledge. So for every input, there are hints to guide you along the way so that you can get some guidance on what to do. And once you hit on get results, it tells you the sample size you need. You can click on show reference to see the formula that was used, because science, after all, has to be reproducible, right? If you did something, I should be able to do the exact same thing and get the exact, well, not the exact result, but get something close to that. So you can copy the formula. These are the parameters that are in the formula, which I explained here. And you can copy the citation and use for your work. So that's what the sample size calculation is all about. The platform also supports sampling. Sampling is if I want to draw a representative sample from, let's say, a country or a state or a location. So imagine I was doing this survey in the US, and I know that I need 1,281 people from the US for my survey. But that only answers half of the question. The other half of the question is, okay, where should I go and select those people from? Right? I don't know. So that's where sampling comes in. So sampling, you go to sampling and you select whether you want to do automatic sampling. You select your country, in this case, the United States. I can then say, all right, I want to access 50 clusters, and my sample size is 1,281, right? Once I click on that, the app will automatically tell me all the places that I need to go. These are the counties, these are the states they are in, and these are the number of people I have to sample from each cluster. And there's also a map provided to help you visualize that. I mean, say a picture is worth 1,000 words. So you can just see that looking at the map, you can see how that cuts across all of the United States. So the platform allows you to sample, whether it is for the United States or for any country in the world. It doesn't have to be countries, it can be subnational entities, or you can even upload your own sampling frame. If you have a particular, let's say, spreadsheet you want to sample from, you can import that spreadsheet and sample from it. The platform also allows you to do surveys. So whether your surveys are cross-sectional or longitudinal, cross-sectional studies are surveys where we collect data at one single snapshot in time, one point in time. So if we're doing, for example, like the evaluation survey, where I just send you guys a link and say, hey, let me know what you thought of the class. That's just a one-time survey. That's a cross-sectional study. But if I were to come back over and over to the same individuals to collect repeated data, that is a longitudinal study. The platform conducts both cross-sectional studies and longitudinal studies. And for the longitudinal studies, you don't have to go and do the follow-up yourself manually. The platform will do the follow-up for you automatically. Because if it's a longitudinal study, it will tell the people that, okay, by the way, there's a follow-up coming up in 1 month or 2 months or whatever you specified. Do you want to participate? If they say yes, provide an email, and that's how the platform automates the follow-up. And like you saw in the demo, it translates your surveys for you. It can tell you the readability of your survey. So here we know that our survey is fairly difficult. The language in the survey is pretty hard according to the platform. It's targeted at 10 to 12 grade according to the Fletch Kincaid reading score. You can offer incentives as well. If you want to pay people money as part of incentives for your survey, you can offer incentives, whether it's a raffle draw or it's a payout for everybody. And then if you wanted to do your survey in a place where there is no internet, the platform has an offline mode where you can collect the data and it's saved on your device, such that whenever you come back to where there is internet, the platform will automatically upload the data into your platform for you, so that you don't have to start doing manual data entry and and start copying and pasting. That again, the whole point is, how do you create a seamless experience for people in whatever you're doing? And so those are some of the features of the platform. And so, like I mentioned, you can use it for any kind of data, whether it's human responses or from animals, or whatever kind of data at all can be collected on the platform. So I hope that provides you with some context for what the platform is. And if you're using it and you have questions, you can always come to our AI and ask any question you have, like, okay, how do I set up a survey on the Chisquares platform? The AI is trained on all of our data. Again, this is one of the things you would have to do as a data scientist. But again, this is just one of those things. So you can ask questions of the AI. The AI has been trained on all of the information we have, and it's going to give you an answer, right? If you don't want that, you can try and generate another response. But essentially, that's how the Chisquares platform works.
Does the Chisquares platform support real-time tracking of data and creation of dashboard relevant in infectious disease surveillance?
Yes, it does. So if we have, if you go to the survey bank, we have, again, surveys of different types. So if you go to health and wellness, for example, we have case investigation forms, we have contact tracing forms, right? So those are forms that you use in the case of an outbreak. You have to investigate the cases, but you also have to investigate the contacts of those cases, right? And that's what we call contact tracing. When you collect data in the platform, the information, you can access it in real time, like we saw in our data. This is our data here. You can look at the responses as they are collected. We have 26 respondents now. You can just download all of the analysis in one click by just clicking on download. If it's not for the whole population you want, let's say you only want to analyze data only among men or only among men who are older, you can say download for a subset of a population, and you can then set up all the subsets to say, okay, education, if we want to analyze for if education is exactly equal to nursing, for example, with submit. So yes, you can collect data in real time, the data analyzed for you automatically in real time. You can download reports in real time for the whole population or for a subset of the population. Any other questions?
Can someone access data for use on the Chisquares platform?
Can someone access data for use? Do you mean exist data from elsewhere, or I don't understand? Or do you mean can someone access your data? Could you please clarify? So if you're doing a survey, you can share your survey with people. That's how the platform has no way of knowing who your population is. So again, that is something that is inherently human. Remember, we said earlier that one of the hallmarks of a suboptimal engineer is trying to optimize that which should not be optimized. It's your study. You know the population. So it's your responsibility to say, okay, here are the people that my survey is meant to be targeted at. So what we can do is provide you with a whole variety of ways to share your survey. You can copy the link. You can share on social media. You can upload emails. If you have emails, you can upload them, right? And then, upload file, and then the platform will automatically send messages for you. You can click here to see the default messages that will be sent. You can edit the messages as you want, right? The platform will then send emails, the emails you've just typed, to all the people that were in that spreadsheet you uploaded. But the participants, define the participants an inherently human task, and that is something that no data scientist should try to optimize, because that takes us back to the hallmarks of a bad engineer, which is trying to optimize that which should not be optimized. So you should know which tasks are inherently human and must be done by a human being, and those that we can automate. Obviously, it'd be wrong if we just say, okay, we'll just take your survey and just propagate it to a whole bunch of random people that you have no idea who they are. That would not be science at that point.
Okay. Dr. Gaku, do you by any chance have a meeting in like 10 minutes?
That's correct. Yes, I do.
Okay. Just a reminder for that. Once you have created an account and built a survey, is it open access to public or private until you want to share?
Your survey is your survey alone. Nobody can access your survey except you and your collaborators. When you want to share your survey, you come to this button and say share survey. And you can say you want to disable link forwarding, in which case people won't be able to access it from social media, right? But you are the one who has to take the step of saying, I want to share it on social media, or I want to share it, I want to copy this link. You see how I copied the link and shared it with all of you? Well, that was a deliberate, intentional choice. I did the sharing. So until you do the sharing with people, they cannot access the survey. And again, if you have emails, you can upload them as well, and the platform will automatically send emails on your behalf. So if you have 10,000 emails, you don't have to start saying, geez, how do I send these emails myself? The platform automates all of that for you. Again, this ties back to what we're talking about data science, right? And how the whole point of hiring a data scientist is to make life easy to solve a problem in a way that is seamless and makes life easy for the users.
What is the maximum size of dataset that can be uploaded on the sites for analysis?
There's no limit to the number of responses in the platform. So you can have, there's no limit to the number of questions you can ask in the survey, and there's no limit to the number of participants who can respond to your survey. So the platform has been built